In this video, you will learn to mentally divide by a power of 10. Now, dividing by a power of 10 is arguably one of the easiest types of division problems to do in your head, because there's a pattern that will make this pretty simple. All right, so for example, if we wanted to divide 5,432 divided by 10, all right, this is as simple as moving the decimal point over a certain number of places. So the question is, how many places do we move the decimal point? And so here, by the way, there's an assumed decimal point at the end of any number. You don't typically write it, but it's assumed to be there. So when you're dividing by a power of 10, we look to see how many zeros do we have after the 1. So there's 1 0 here, which means that's how far we're moving the decimal point. So it moves one place over, and it's going to go to the left because the number needs to get smaller. So the number now becomes 543.2. So it had 1 0, so we move the decimal point one place. And another way we can think of this is we can think of 10 as 10 to the first power. And because the exponent is 1, we move the decimal one place. Okay, now what if you divide by a different number? What about, instead of 10, what if we divide by 100? So again, same logic. We see that there are 2 zeros after the 1. So that means we need to move the decimal point 2 places. So the decimal point moves 2 places to the left, goes from here over 1, 2 to get 54.32. So again, there's 2 zeros after the 1, so the decimal point moves 2 places. Or we can think of this as 100 being 10 squared. So because the exponent is 2, that's why the decimal point moves 2 places. Okay, so hopefully you're seeing the pattern. We can do this for any number of zeros after the 1. Let's say we divide by 1,000. Now we have 3 zeros, which means we need to move the decimal point 3 places. So it goes from here over 1, 2, 3 places to the left, and that becomes 5.432. So again, there's 3 zeros, so we move the decimal point 3 places. Another way of thinking of this is 1,000 is the same thing as 10 times 10 times 10, which would be 10 to the third power. All right, so 10 to the third power, the exponent is 3, so we move the decimal point 3 places. And then one last one on this slide, if we divide by a 1 with 4 zeros, or 10,000, we see 4 zeros, so we move the decimal point over 4 places. So it goes over 1, 2, 3, 4, and we get 0.5432. So 4 zeros moves it 4 places, and we can also think of this as 4 tens multiplied together. So 10 times 10 times 10 times 10, that's 10 to the 4th power. So that 10,000 that we're dividing by is actually 10 to the 4th power. So the exponent is 4, so the decimal point moves 4 places. So this is the same logic as multiplying by a power of 10. So with division, the decimal point moves to the left. With multiplying, the decimal point moves to the right. All right, let's try some practice ones. So try to do these ones on your own without my help, but I will explain these as well for you. So here we have 862 over 100, and the question is, what is this equal to? All right, well, to do this, we can think of 862 over 100 as a division problem, so we are dividing by 100. So again, because we're dividing by a 1 with 2 zeros, the decimal point moves from here after the 2 over to the left 2 places. And that gives us 8.62. Now what about 47 over 1,000? So here we are dividing by 1,000. And the decimal point is starting here after the 7 for 47. So when we move this over 3 places because there's 3 zeros, we go over 1, 2, and then we go over one more place to the left, which means we have to add a 0 in the front, and the decimal point goes in the front of that. So our solution would be 0.047. Now what about 6.3 divided by 1,000? So again, we're dividing by 3 zeros, which means we need to move the decimal point over 3 places from here. So it goes over 1, and then it moves over 2 more places after that. So we have to add 2 zeros in the front to get my new number of 0.0063. So now we know how to divide by a power of 10, and we can use this as well to try to maybe estimate a division problem. So for example, if we wanted to estimate this quotient, we're trying to do 6,835 divided by 115. So one approach we can use is we can realize that 115 is close to 100. So I can think of this as 6,835 divided by 100 to get an approximate answer. So dividing by 100, the decimal point would have to move 2 places because we're dividing by 2 zeros. So it goes from here over 1, 2 places to get approximately 68.35. So this is our estimation using this approach, whereas the actual answer is 59.43. So it's kind of close. This gives us a ballpark number. All right, let's try another example. And this one is a little more complicated, but hopefully not too bad for you. Here we have 68,135 divided by 587. All right, so this one, 587, is kind of in the middle. It's not really close to 1,000. It's not close to 100. But I can think of this as being close to 600. So it's close to 600, which is 100 times 6. So it is close to a power of 10, the 100, but multiply it by 6. So what I can do is I can think of this, instead of dividing just straight up by 600, we can think of this as dividing by 100 and then by the 6. All right, so what I can do is I can do 68,135 divided by 100, and we're dividing by factor 10 to the second power, so this would be 2 zeros, so the decimal point moves over 2 places. So we get 681.35. So that's 681.35, but then we also have the divide by 6 out here. Well, we can kind of estimate this as well. 6 times 10 is 60, 6 times 11 is 66. What if I round this to a 660? Well, 660 divided by 6, we can do 66 divided by 6 to get 11, and then put a 0 at the end, that'd be 110. So using this approach, we can estimate to be close to 110, where in reality, the actual answer would be 116.07. So that was pretty close, realizing that we were dealing with some pretty large numbers, and we're only off by 6. So this approach can be helpful to estimate even large numbers like this. And that concludes our lesson for today. We will see you next time.